Hello everybody. I'm going to present to you this position paper that is about autonomic orchestration of containers, and I will define the problem and I will talk about the research challenges in autonomic orchestration, and I will mention also research challenges about containers. So this research is partially funded by the Big Data at BTH project, that is a consortium mainly founded by the KK Stiftelsen Swedish research agencies, and by other companies like Ericsson, Telenor, Sony, and other local companies. Why I've decided to investigate the problem of containers orchestration? Just to rehearse the concept of containers, a container is a software environment where one can install an application or application component that's called microservices. And inside the container, you can install all the library dependencies, the binaries, and the basic configuration needed to run the application. And so a container is a self-contained environment that can run on edge systems that support the container format. And the difference between containers and virtual machine is that while the virtual machine hosts its own operating system and run on top of an hypervisor that can run on top of an operating system and then on top on the hardware, the container run directly on the operating system that run on top on the hardware. So it's a lightweight virtualized environment, and there is a container manager that manages the execution of the containers. For example, Docker is one of the largely used containers managers or containers engines. And containers allow to solve the dependency help problem, the application portability problem, performance overhead problem, and more, easy to deployment problem, and so on. And IBM foreseen that the new cloud operating environment will be built using containers as a foundation and no more virtual machine. And so I think it's important to give a contribution from a research point of view to what will be the infrastructure of the next generation cloud. And one of the main problems in container is that technologies are far away from the maturity stage. For example, monitoring of container is not mature, resource management at runtime is not mature, orchestration, policy and adaptation model are at their infancy, and there are no autonomic solution for the adaptation of containers. And the focus of my research is on the orchestration problem. And when I talk about container orchestration, I talk about how to select, to deploy, to monitor, and to dynamically control the configuration of applications that are composed of many containers that are packaged together to achieve a common goal. And these containers run, of course, on cloud infrastructures. And when we talk of containers, we have an even more dynamic and complex environment than in virtual machine, because with containers, the number of components that we have to orchestrate and to manage is higher. Let's, for example, to think about big data application that use containers to run the functionalities to process the portion of data. This is a classical example of use of containers. And right now, there are solutions for the management of containers, but as I said before, they are not yet mature. Let's start from how containers are supported from the operating system view and from the cloud provider side. There is no mature operating system that purely supports containers. What I mean, there is no operating system that offer all the functionalities to manage containers, like, for example, an hypervisor for virtual machine. There is CoreOS that is an ongoing project, but is not mature. And the provider right now use the solution to run container on top of virtual machine. And in this way, they lost some of the advantages in run containers. And the solution is, and this solution is adopted because in that way, cloud provider can use and can still use the management and orchestration mechanism used for virtual machine, because you reduce the problem of managing the resource for containers and orchestrating containers, managing the resource for virtual machine and orchestrating virtual machine. There are tools that allow to orchestrate containers, for example, Kubernetes, but these tools do not offer dynamic autoscaling algorithm, sophisticated dynamic autoscaling algorithm. They offer simple threshold-based policing for load balancing and for autoscaling. But one of the good points of these tools is that they offer API to design third-party controllers. For what concerns the management of cluster of containers, also here there is Worm, that is a tool that allows to manage cluster of Docker containers, but the management is static and there is no dynamic management of clusters of containers. And so there is a lot to do in this area from this different perspective. And the problem I want to address is the problem of, as I said before, or autonomic orchestration. And if we consider a data center running containers, we have different cluster nodes. On each node, we have a container engine like Docker and the containers running the different application components. And we have to manage the resources for running these containers. We have to scale the containers. We have to guarantee that containers are reliable, and all this must be done in an autonomic way, like for virtual machine. And so the natural approach is to apply the classical MAPE controller to the container orchestrator. But the problem that we have to address is how this controller must be designed. And the options are to go for a centralized solution or for a distributed solution or for a hierarchical solution. The problem of managing the events that trigger the adaptation and when to do the adaptation, the time perspective, considering also that the adaptation have a design phase and a deployment phase, and that changes for orchestration can be done first at design phase, and this must be synchronized with the deployment phase. The problem of where to run containers, so the location perspective, and the choice of the location where to run containers could depend on many factors: quality of service constraints and objective, legal rule compliance constraints, and management of failure at both software and hardware layer, and energy consumption optimization, and so on. So there are different reasons to manage the location of containers. And the management of the location of containers, or where to run containers, is a problem that is of high interest also for internet service provider that see in container a better solution than virtual machine for running networked virtualized services. So there are a lot of work from the networking community that use containers to run networked virtualized services. But what are the challenges in orchestration? First of all, there is the problem of monitoring the containers, because the techniques, the classical techniques used for operating systems are not good enough, and so new techniques must be deployed. The problem of defining a workload characterization of containers running on top of bare metal or virtualized environment. The problem of profiling the performance of containers. For example, there is no agreement on what should be the quality of service metrics for container-based systems. And there are no performance models of container-based systems. And there are no adaptation model, autonomic adaptation model for container-based systems. This because lack of characterization, lack of performance profiling, lack of performance model, and also a real understanding of what are the real system constraints, like, for example, the synchronization between design and execution environment. So the goal is to go for designing a framework that allows QoS-aware, energy-aware, eventually legislation-aware, optimal adaptation of container. These are the main challenges related to orchestration, but of course there are more challenges in other fields, like improving the I/O of containers. This is the weak point of containers. Hypervisors offer better performance in managing the networking and the I/O toward the storage. There is the problem of enhancing the security isolation of containers and secure resource sharing among containers. And also there is another problem that is related to the design of container-based application, because on one side there is the possibility to fragment an application on microservices, but there should be a trade-off between the number of microservices and the performance in managing a huge number of containers. So to conclude, I think that there is a lot of work to do in containers, and this is a not yet widely explored field. There are research work, but not yet good and mature solution for what I mentioned before. So thanks for your attention, and so if you have questions, feel free to send me an email.